Hello students, welcome back. We went through the definition of the complex numbers and some algebra of complex numbers. Addition and subtraction, easy. Multiplication, that too is straightforward. Division, that's different. And we went through example problem like this and also like that. And basically the key point is to multiply the conjugate of the denominator to both numerator and denominator so that I don't change anything, just multiplying by 1 in the end, but that'll magically transform the denominator so that I just disappears and then you just have a single real number, so that you can break up the numerator and then you have x plus yi form like this and also like that. And then once you have that, you can do addition, subtraction with other complex numbers. So complex division, yeah, remember that, that's important, especially for exam purpose. Now let's talk about some other aspects too. Complex roots of quadratic equation. Okay, alright, I sometimes write these kind of problems too. Not as often as complex division, but here we go. Quadratic formula here, but what if the inside of square root is negative? In that case, you can keep it as negative inside, but better way is to make it positive by taking absolute value and put I. Was an example problem? Okay, alright, here's an example problem. Okay, let's go ahead and do that. Let's copy and paste this quadratic formula. I think 1 is a bit too easy. Let's do this one. Okay. And then let's copy and paste one some more. And then in place of A down here, I have to put 25. And then A is 25, so 25 goes here. B is negative 10, so negative 10 comes here. Oops, negative 10, excuse me. And then here, negative 10 comes in. Negative 10. And finally, C is 2. You need this computation. Let's simplify just a little bit more. Negative of negative 10, so this is positive 10. And then negative 10 squared, positive 100. And then, sorry, I should have completely removed C. 4 times 25 times 2. 4 times 25, 100 times 2, so that's 200. So this is 10, no, let's copy and paste once more. Oh, by the way, denominator 2 times 25 is 50. And then here, I can write negative 100. Or equivalently, we can write as positive 100 and then I. So positive 100 and I, like that. We can write like this. And that'll help you simplify. Square root of 100 is 10. So you end up with 10 plus or minus 10i over 50. And then dividing each by 10, we get 1 dividing each by 10, 1 plus 1i over 5. Nobody writes as 1i, so 1 plus or minus I over 5, or in other words, no, let me write a separate line. X is 1/5 plus 1/5 I, and another answer is x is 1/5 minus 1/5 I. And please recognize this. These two answers differ only by the sign of the imaginary part. The real part is identical, and imaginary part we have plus or minus part. In other words, these two are conjugate of each other. Always you're going to get that. And the structure is pretty straightforward. That's because plus or minus square root and plus minus square root part may come with I. So that imaginary part comes with plus or minus. Everything else stays the same. And consequently, we have to have the conjugates. What do I have here in this answer key? Oh, exactly the same. Exactly the same, except the fonts are a little bit smaller, a little bit harder to read maybe. And then there are more problems. Let's see, we have a quadratic equation here. Don't be intimidated. You can solve for x squared, and then later you can take the square root of that. Same goes with this one. So in this kind of problem, x squared plus 9, x squared plus 4, that's going to be your factorization. 9 times 4 is 36, day after positive 13. And it's not x plus 9 and x plus 4, because if you have that, then that's going to be a quadratic equation, not quadratic. X squared square, so we end up with x squared plus 9, x squared plus 4, and setting x squared plus 9 equal to 0, we get squared plus 9 equal to 0, x squared equals negative 9, x is plus or minus square root of negative 9, but that's the same as, yeah, plus of square root of 9i. And what is square root of 9? Plus or minus 3i. We get that. And then a couple more from here. X squared plus 4 is equal to 0. X squared is equal to negative 4. X is plus or minus 2i. Square root of 4 is 2, but we have square root of negative 4, so we have I. So plus or minus 2i. Previously, plus or minus 3i. Turned out we didn't need quadratic formula. Did I use quadratic formula here? I didn't use quadratic formula here either. And this one doesn't look like quadratic formula problem either. You can just factor it. And then x squared is equal to 4. Okay, alright. Let's suppose we have this factorization. And this factorization, I think it's a bit of an overkilling, so let's not worry about this part. So we get x squared is equal to 4 from this x is plus or minus 2. So we get x is negative 2 or x is positive 2. And then from the other, 2x squared plus 3 equal to 0. 2x squared is negative 3, so x squared is negative 3/2. So x is plus or minus square root of negative 3/2 but you can rewrite it as plus or minus square root 3/2 and then I. So whenever you have square root of negative number, change it into square root of positive and then put I, and that's the way you can get a complex number. So we have in this particular case 4 solutions, plus or minus 2, so there are 2, and then plus or minus square root of 3/2i. There are 4 solutions. Here you can factor further down to this, and then x is -2 or +2, and you can do it like that. If you can see this further factorization, if you see that as highlighted in green, then you'll be able to see this. But that's a bit of an overkilling. From here you can go directly to this. Let me take one more step. So x squared minus 4 is 0, therefore x squared is 4, so x is plus or minus 2. Yeah, there goes 1 from the first factor. From the second factor, square plus a positive number. In that case, you're going to get imaginary solution. Okay, so much for complex numbers. That concludes section 1. Quadratic formula, that's important, so review that. And whether you have square root of something negative, usually it's better to write square root of positive times I. And finally, the most important of the bunch, complex division. Multiply the conjugate of the denominator to both numerator and denominator. Especially for exam preparation, remember the complex division. It has high probability showing up, higher than the others.